Emiliano, welcome to this episode of the NewSpace India podcast.
Thank you. Thank you for having me.
So I think we are one of the most inspirational person that I've talked to, at least in my podcast so far, having read the story of Satellogic and how you have built up the company over the last 10 years. And as I see it from having read your profile, you're not originally from the space industry, but you entered the space industry. So just to kick off the show, let's talk a little bit about your background and what got you into the space industry.
Sure. So my formal background is in mathematics, but I have never worked as a mathematician. So a frustrated mathematician is what I usually list as my profession. But I've been building technology companies all of my life. I started programming computers very young. I started my first software company when I was 15 years old. And I've been basically building tech companies since then. I'm 45 now, so it's been 30 years of building technology companies in a sense. Initially, I was very taken and focused on information security. So the first couple of companies I built were information security companies. When I was 19, I started a company called Core Security with a group of friends. We took that company to around $40 million in revenues, and we had at the time 250 people doing R&D in Argentina, where I'm originally from. We set up the headquarters of that company in Boston, and we were doing essentially software to test the security posture of organizations. So software would allow network admin or an information security officer to break into their own systems to figure out where the problems were. And it was interesting and quite a ride. I did that for many, many years, around 12 years. And eventually, I sold my stake in the company. I started a venture firm to invest in technology companies, early stage, because I thought that would be at the time, I thought that would be a way for me to be able to, do something a little bit more meaningful. And I soon realized that wasn't the case, right? I didn't like being on the other side of the table a lot. I was very frustrated with the experience of, having to kind of, the beauty contest of having to select where to invest and having to say no to 99% of the things that you look at, and finding reasons for things not to work, right? Finding risk and things. And I think I'm kind of more of the guy who would try to look on the positive side of things and how can we make things work, right? Against odds, basically. And I think the posture is very different. So I learned the discipline, but I didn't enjoy it that much. And I also think I didn't enjoy the kind of deal flow that I was seeing a lot. I was seeing a lot of very smart people focusing essentially on targeting advertising, and finding new ways to position and sell ads in front of one another. And, I was kind of disappointed at that. I thought, smart people should be trying to solve the big problems that we have. And in my mind, those problems revolved around food production and distribution, and energy generation and distribution, and how we manage natural resources to do those things for a growing population, in a world that's ever more volatile, in a way that allows everyone to enjoy better quality of living. And those problems were kind of hard to tackle, right? And I didn't see a lot of people doing it. So I started thinking about starting a new company around these ideas. And, I ended up building satellites. Probably not the most natural progression, but that's just how it happened, right? The reason for it is I understood very quickly that satellites were particularly well positioned to look at what was happening in the planet. And if we took the big problem areas that I was interested in, one of the things I realized quickly is that humanity doesn't really have resource availability problem, right? We have enough sunlight and we have arable land, and to feed and give energy to 10 million people if you want and more. What we have is a resource optimization problem. It's how we use the resources that we have, what we put where, how we deal with food security issues, how we deal with, using the natural resources in a way that we can make this sustainable for future generations. And that's all optimization issues. And if you look at these optimization issues, there's trade-offs between the different things that we can choose to do with our resources. And to analyze those trade-offs, we really didn't have, and we still don't have, a good framework, a good systematic framework. And part of the reason I understood was because the information we were trying to use, so the data we were trying to use to feed the decision-making models was pretty stale, very old, in a world that, as we were saying, was increasingly more volatile, and I thought would continue to be increasingly more volatile over the next decades. And 1 decade later, I can say that's clearly the case. And so I figured, well, we need to just build an infrastructure to go and collect the data that we need to feed better decision-making models. Today, you would call that, kind of the geospatial information data acquisition infrastructure. At the time, probably would have called it similarly, but we didn't use those terms. And but I figured satellites were really well positioned to do that. Then the issue became, kind of, at the beginning, I didn't know if the issue was a basic physics issue or it was kind of a engineering/business model issue. I knew satellites were well positioned to collect data over all of the planet. I learned quickly that depending on the resolution that you want to get on the data that you collect, the granularity that you want, you might take, a satellite might take a certain period of time to remap the entire surface of the planet at sub-meter resolution, which is where I was looking at. A satellite will take, a little bit over a year, maybe, or in the order of a year to remap the surface of the planet. And one thing that excited me was that it was linear, right? So if you had one satellite that remapped the planet at, sub-meter resolution in a year, you put 360 satellites and you can do it in a day. So essentially, I figured this is what we need to do. We need to put enough satellites out there that we're essentially remapping the surface of the planet every day, and in high resolution, sub-meter resolution. And well, I set out to do that, and basically because I didn't know it was so hard. That's kind of the story of how the company got started.
Yeah, that's quite amazing. And I saw that you went to the US and you spent some time around the NASA Ames Center, and you probably talked to some other people there, and then made your conclusions on some of these ideas. At that time, what was the status like in your region? Because you said you are from Argentina, and I know the Argentinian Space Agency was involved for many years in space exploration. When you wanted to kick off your venture, was there any traction with the Argentinian authorities? And what was the reception like?
Yeah, so I think this is an interesting story, and it has parallels. I think can have parallels for India for sure. As you say, I'm from Argentina. When I started with this idea, I went to NASA Ames in Mountain View in California. I ended up spending most of a year actually talking to people there, trying to figure out, how satellites were built, if I had to break laws of physics to make what I wanted to make. And, after a year of talking to people there, I realized a couple of things. One was that this was definitely possible. I knew I kind of had an idea of how to do it. The biggest concern was reducing the cost of the satellites because, high resolution imaging satellites at the time cost a few $100 million a piece, and I needed to put hundreds of satellites in orbit. So I needed to find a way to reduce the cost of the satellites by a factor of hundreds, let's say. And I knew that was going to be difficult, but after a year, talking to people and looking at how things were being done, I realized I knew and I could figure a path to do that. Then I looked at the regulatory environment for building and operating and launching and operating a large constellation of satellites from the US. And I realized very quickly that I actually didn't want to build the technology in the US, that it didn't make sense. There's just a lot of regulatory burden around ITAR, so export restrictions, and around licensing restrictions, and a few other things. And I just didn't want to. I had dealt with ITAR and export restrictions in my information security days, and and I knew the overhead involved, and I just didn't want to have to deal with that. So I knew I wanted to build the satellites and build the technology somewhere else. And Argentina, and I think India is in a similar position, but Argentina had several decades of experience in building space technology, mostly concentrated around two centers: the CONAI, which is the space agency, the National Space Agency, and the company down in Patagonia is called INVAP, that has been a provider for the space agency, and they have built a lot of the satellites. They have the high base. They have built a lot of the satellites in their facilities for them, and they had some collaborations in the past with NASA. They had flown some research satellites or scientific satellites, and they were building at the time even a couple of communication geostationary satellites. So at a small scale, there was a whole wealth of people with knowledge and experience in building space technology. And so what I did was I basically called two people. I called, I had the luck, in a sense, of because of my previous career in technology, of knowing a lot of the people involved in technology in the country. So I called the Minister of Science and Technology of Argentina, and I told him, this is what I want to do. I want to build, hundreds of satellites. There's going to be, I try to implement a completely novel business model for this industry, and I want to build this technology in Argentina. And he basically said, look, if you come back to Argentina to build this technology here, we're gonna find a way to support you, at the beginning. And I think I was encouraged by that, of course. And then I called the person who ran the aerospace business at INVAP, this company, Patagonia, and that I also knew from before. And I talked to him and said, look, Tulio is the name of this guy. This guy said, look, Tulio, this is what I want to do. And he said, you're completely crazy. This is impossible. It cannot be done. But it's great. And so he essentially, I asked him, I basically told him, look, what I need is, I need people to talk to, right? Because I know nothing about space. And so I need people to talk to, and I probably need to use, your facilities and equipment. And so just let me go there and set up, in a corner somewhere around there, and spend a couple of years building, my first satellites. And he said yes. And so with these two avenues of support, eventually the Ministry of Science and Technology of Argentina ended up giving us a contract for a little bit under $2 million that allowed us to finance the launch of our first two satellites. And so we spent really 2 years, 2011 and 2012, in full, and half of 2013, started the company, essentially incubated inside INVAP in Patagonia, with the contract. We had some seed money from angel investors, but we also had this contract from the Ministry of Science and Technology. And there we built our first two satellites. We built and launched our first satellite, Capitan Beto, that we launched in April 2013. And we started building our second satellite that we ended up building in a different location and launching later that same year, later in 2013, October or November, if I remember correctly. And that was a great start. And I think, I always say this is a good example of how governments can support, early stage startups in this industry. One is by opening up the the facilities and the capacity and the, and the know-how of the existing space community, right? And INVAP did just that. We were able, when we were there, we weren't employed because we wanted to do something a completely new way. I wasn't hiring aerospace engineers, right? I was hiring people right out of school. I was hiring, smart people that were building software and electronics and mechanical engineers and so on. But I wanted them to be able to talk to aerospace engineers to essentially, have a faster learning curve about how to build space technology. And this contact with engineers that had experience, that have been doing this for a while and so on, was extremely helpful. And I think it accelerated a lot our learning curve at the beginning. And then, of course, the early support of the Ministry of Science and Technology with some instruments that allowed us to finance, the early stages of development were also very, very important. Then at one point, after a couple of years, it was time for us to go and do our own thing. So we left kind of the incubation stage, if you want. We left INVAP. We raised money in the private market. We set up. Actually ended up setting up in Buenos Aires, so a little bit far, different city, far away from Patagonia, and we started iterating on the next generations of our satellites. In the second stage, I say, having as little contact and as little support from the government as possible is also important, right? Sometimes, and sometimes what happens when governments get fixated on trying to develop an industry is that they will give too much support also to companies, right? So they will keep alive by, funneling contracts and subsidies and so on. They would keep alive companies that should be essentially allowed to die, right? I mean, this is normal. I mean, companies to die is important also because it allows people to learn, right? If you try to do something and there's no market for it, well, it's better that you fail and you learn and you go back and do another thing, or maybe one of your employees goes back and does, and learns something and does another thing that actually makes sense. Particularly if you don't have, a huge volume of startups. I think it's also important. It's important to know when to support the startup, and it's also important to know when to stop supporting the startup and let them, see if they fly, right? And I think so. This was also, what happened to us. So around mid 2013, we essentially. From 2013 on, we've been, we never got a subsidy, we never got a grant, we never got a government contract. We essentially had to figure out a way to make it work privately. And I think that's also, good in sense of things that we can learn from the experience. I think both those things are important.
That's an absolutely amazing background story to all of this. So I have two quick follow-up questions to that. One is INVAP a government-operated company or a privately operated company? The second one is that you talked about these grants and access to the minister and so on. Would it be possible? Is it that since you had a background of building a successful technology business prior and people knew you quite well in the social circles at very high levels, would it have been very difficult for others who are possibly very new in the system to replicate what you did then?
Yeah. So the first question was about INVAP. INVAP is a state-owned company. It's actually a province-owned company. So it's not the national government. It's owned by a provincial government, but it's a state-owned company in Argentina. The second question, of course, counterfactuals are difficult, but if I have to guess, I'd say yes, it was definitely a big advantage. I would say not only in when talking to the government, but also when talking to private investors and when trying to recruit people. That I had a previous history building companies that people knew in Argentina, right? If I had tried to do this, if I don't know, had gone to India, for example, tried to do this, nobody knew me. It would have been very, very hard, right? Because I had a lot of things going against me. Right? I was trying to build a space company. I had no background in space. right? People had no right to believe that I knew what I was doing, right? And I was also trying to do something that sounded to experts in aerospace completely ridiculous, right? When you talk to them, they say, what this guy's trying to do is it's impossible, right? And so, you know, that would typically, if I didn't have a reputation for building technology companies and doing things, I think it would have made it significantly more difficult for me to recruit people, significantly more difficult for me to try to raise money from angel investors, right? Because they had, you know, basically everything was stacked against me. And I think it will also been a lot more difficult to, you know, for the government officials to essentially, you know, give me a grant, or for a state-owned company to like open doors and tell me I'd come in and you know, and sit in the corner. So definitely think that was a big part of it. I think it's also different now in the sense that once, you know, in a sense, I was kind of the first, not exactly the first, but probably the first private aerospace company in Argentina that tried to do something at a certain scale. And afterwards, you know, this has created a couple of things happened for it. I think the last 10 years, of course, the NewSpace industry has developed a lot. And then in Argentina, having one example of a company that was doing this, I think was also helpful for other people to, you know, to believe this could be done in the country, to believe that, you know, the talent was there, to believe that you know, that this wasn't crazy and you had to be, you know, at NASA to go and do these things. And so I think that is also important. And you can see now in Argentina, I mean, there's not a huge ecosystem, but there's probably around 10 or 15 new space companies that have started over the last few years. And of course, if you know, Argentina's population is around 40 million people, right? And I think we kind of have the same, you know, the history. I mean, less aerospace experience than India for sure, you know, and probably more startups, right? In aerospace, which, you know, with that very, very small population comparatively, right? So I think there is a, you know, an ecosystem effect that is created by kind of the pathfinders, you know, the companies that build the first and that show that this is possible, that this is possible to do there, and so on. And I think we played a little bit that role for the aerospace industry, and maybe continue to play that role in a certain sense in Argentina. And I think, you know, for the company that plays that role, maybe they have to have some unfair advantages like I had, in the sense of, you know, starting from a place that allows them to break this path of resistance, right? But for the companies that come after it, that's just not the case. And it, you know, if you look at the next generation of companies started in Argentina over the last few years, you know, they didn't have founders that had particularly any track record. But what happened is people started to believe that this was possible, and you know, started to be open to the idea of being pitched aerospace companies, and I think, you know, that's a good process, I think. Yeah, but it could have worked different ways, right? If instead of having built technology companies before, I came from the aerospace industry and was, you know, a very well-respected engineer from the aerospace industry, I think it could also be enough to kind of build this credibility, right? It's, in a sense, it's around you know, steps to build credibility and reduce risk, and you know, and how you do that, so that you're allowed to essentially continue to try to build.
Right. And when you were trying to build your team up, there's two problems that you face, right? One is, of course, the kind of the quality of the team in terms of the experience. And you said you were trying to recruit people off of university or so on. And so one part of it is, did you see a lot of the traction for, you know, movement of the IP that was built up in the space agency, and the credibility and the heritage flow down to what you were trying to build? The second part is with respect to the supply chain. You see, you know, even in countries like India, we don't have a lot of the semiconductor base for, let's say, having solar cell manufacturers within India, or, you know, imaging sensor manufacturers in India. So we import a lot of it, but then we put the IP together in a way we can do the AIT. And it seems like that is what you also did. So what is it that you can comment on these two particular aspects that gave you, in a way, some unique benefits of the, building out of Argentina?
Right. So the first thing on the first topic, what I would say is we were trying to do something very different than the way it was being done by the aerospace industry then. I mean, even today, I would say the idea of building satellites out of commercial off-the-shelf components, and the idea of doing agile development for satellites and continuous software integration. So these are ideas that have taken on in the last 10 years. And today, this is not crazy. And today, actually, space agencies have tried, attempted, and done, versions of this internally. And so this is kind of established concept now. But when we started back in 2010, 2011, this was considered sacrilegious, right? And space agencies didn't have any history and any know-how, any specific IP that we could reuse, right? So we had to build it all from scratch, basically. And so we never really looked closely at being able to reuse any IP coming from space agencies, because basically we thought it would just be too expensive, too old, too cumbersome. We just need to build it new, right? So that was one part, which made things easier. I mean, we were trying to, we were the reason we wanted to be close to INVAP. We wanted to be close to people that had experience in aerospace, is because they basically, like, if you might spend at the beginning, you don't even know what the problems are, right? Like, so particularly because we didn't have aerospace engineers and we didn't want to hire aerospace engineers. So it's like nobody had learned in school how to build a satellite, right? We had to essentially figure out what needs to go there and how to put it together and where the problems were. And that helped us a lot. On the supply side, I think coming from Argentina, again, we just never assumed that we would have local supply for what we wanted to do, right? So, I mean, for some things we tried, like, machining of some precision parts, and in aluminium, for example, the kind of thing you can probably do locally. And there was a group at an institute that had experience assembling solar panels out of solar cells that were coming from Germany, and we could tap into some of their capabilities. And we, over time, had a couple of suppliers locally that we tried, but we always knew that we had to plug into distributed international supply base. So from the beginning, we set out to do that. We set out to establish the connections to around 100 and something suppliers in 30 countries, basically, and gather component and essentially, in some cases, even do we would design things that they would build for us to specification, and that we would integrate into our satellites, right? So we established this international network. I think this was a big part of how we approached it. Today, I think you can, you can do that. I mean, I think we were essentially taking advantage of the fact that we could do computer aided design and even testing in some cases, and that we could do rapid manufacturing to test things, and that we could take those things and build them into a satellite without having to build all the parts ourselves, right? So I think that was how we approached it. Eventually, what happened is the import and export regulations and processes in Argentina just weren't up to what we needed to be able to do this at scale and do it fast and essentially do it in just in time, because when you're or satellites are, they have 450 different subassemblies. Each subassembly has maybe 20 different components. So you're talking about, 10,000 components that you need to source and integrate. And also you're a small company not a lot of budget. So you don't want to have, a year of inventory sitting in the shelves, right? So you want to do this with minimum inventory, and so you want to do that kind of just in time or real time. And one thing is to build a prototype or two prototypes where you can go through the hoops of how you import the things and how but when you have to build an assembly line, right, as we were doing, at some point the regulation in Argentina for imports and exports was just too cumbersome for us to deal with. And what we did is we went and set up a manufacturing facility in Uruguay across the border from Argentina in a free trade zone, basically. So operating inside of a free trade zone, basically, or manufacturing integration or AIT facility inside of a free trade zone, basically guaranteed that we could get things in and satellites out as fast as we needed, right? And I think that was also a big piece of how we managed to deal with the complications that I'm assuming you will have in India as we had in Argentina, right? So I think this is a great tool if you can replicate it. It's just being able to build a space park with a free trade zone, in a way that essentially allows you the chance to really integrate into a global supply chain in a very direct way, right?
What about the access to frequencies, license to sell satellite imagery? I mean, these are things that you touched upon from the US perspective. And given that you have now an assembly center in Uruguay, but you are operating out of Argentina, how does it work? Is it easier to get it out of Argentina?
Yeah, so frequency coordination, the interesting thing is, frequency coordination, you can pretty much, you need a sponsor. I mean, you need a sponsor country, and you need for both things, for registering the satellites in front of the UN and for frequency coordination. They don't have to be the same country, actually. Ideally, they are. They don't have to. And so, yeah, I think that there it's just a matter of, of the country having the dynamism that is necessary to, and the structure that is necessary to support, interfacing with the ITU and dealing with, because it's not a complicated process. It's not a costly process, but it's a process. You have to be able to do it and manage it, and the country has to have the capacity or the institutions to, with the intention of supporting, companies to do that. What we found working out of countries that didn't have a lot of experience, because we were essentially the first private company to launch satellites, both from Argentina and Uruguay, I'd say. What we found is that, space is a very sexy business, right? And people want to help. Like, this is the thing, right? Like, if you talk to people and say, like, yeah, we're trying to put these things in orbit, they want to help you. They want to help you do that. And so we found that to be a great way to approach people, and we had a lot of support. And I think I wouldn't think that's a big complication in general. I mean, it's just, it's a process. You have to go through it. And regarding the imaging licensing, different countries have different rules and different regulations about what companies in the country can do in terms of capturing imagery and selling imagery, but also different countries have different regulations of what kind of imagery you can sell locally, right? So when it comes to what we sell and where we sell it, of course, we have to comply with every country's regulation when we sell in a particular country, right? When it comes to the regulations for operating constellations of imaging satellites, well, Argentina and Uruguay don't have any regulations when it comes to operating or any licensing requirements to operate a constellation of imaging satellites. This, I think, is advantages compared to the US, where you have to go through a NOAA licensing process and so on, even though it's, there's been some changes in the regulation in the US and it's getting significantly better and easier and faster than it was, when I looked at it 10 years ago and decided not to deal with it. I also would say that, being in a place where the regulations are easy and simple, and I think make things, of course, significantly easier, right? And the legal overhead and just the headaches of having to deal with paperwork and bureaucrats and government needs. I think all of that is, I think it's helpful. Of course, the counterpart is, and this, it's probably, it's the counterpart is, yes, the ecosystem is a lot less developed. You don't have a large local supply chain. You don't have a lot of, as many people trained. You don't have a lot of previous experience of people building startups. You don't have the venture capital. You don't have, there's a lot of things that you don't have, right? But you can also enjoy some of the benefits of the things that are not there, right? I think the worst case scenario would be probably if you have a lot of regulation and none of the ecosystem basically to support company formation and company growth, right? I hope that's not the case in India, but in the US you have both the perfect ecosystem to support company formation and company growth, and you also have a long history of regulation space, which makes a lot of sense, and a lot of government and defense interest that makes it heavily regulated industry. As a dual use industry makes it a heavily regulated industry. You go to a country like Argentina, you don't have anything. You don't have the ecosystem, but you also don't have the regulatory frameworks, right? And sometimes if you can navigate that, that makes your life easier, right? At least in some ways.
Yeah, that's an interesting point, because that is exactly what I wanted to ask you next, is which is the investors, because it is maybe easy to raise 1 or 2 million in seed or even Series A venture capital in at least in countries like in India. You can raise a little bit of money, maybe up to 5 million or so on in some VC funding. But beyond that, raising money in especially like a high-tech sector in space is really, really difficult, because the fund sizes are itself very small. So you can't expect, an investor. I, don't foresee traditional VC, fund investing like 50 million in a space startup in India. That can only happen through a extremely large family office or some other instrument, or even maybe then international investors. And I saw that you did raise money from Tencent and a few others. So obviously you had to go abroad to look at investors who were interested in investing capital. So how did this whole process occur, and what made you to choose some of them?
So we've raised a little bit over $100 million over the years. And we never raised from any large amounts from traditional venture capital firms for a few different reasons. First, the venture capital environment is not as well developed in Latin America. The venture capital that is developed in Latin America is focused on other industries, right? Mostly retail and other things. So I don't think there was ever a possibility. The venture market in the US is in theory open to investing in companies that are not from the US. And if you have the right, kind of reasons for not being there and so on, it's not completely impossible, at least in theory. In practice, what I found is that, the dollars don't always follow the way people talk about what they do, right? So I think it's not impossible. It's just it's just a burden, an additional burden. And situation might be different today, but over the years for us, we were in an industry that VC is not very familiar with, right? Venture capital does not have a track record of 20 years of investing in space companies, and they cannot identify which ones are going to work and which ones are not going to work. Right? Like venture capitalists are essentially pattern recognition and pattern matching machines, right? And if they can't find, the pattern to success, then it makes the decision significantly harder. There's still individuals that can make those decisions, but it makes it significantly harder. So you have that. You have the fact that you're a foreign company, and you start putting the things together, and you start adding risk to any potential investment, to the point that I agree with you, it's probably unlikely that's going to happen for an international company to raise venture capital in this industry, even today. I do. So we focused from the beginning on two different funding sources, and we've talked to every venture capital out there, but we focused on two funding sources. We focused on family offices, as you said, and we focused on strategic investors. So companies that have, because they are in the markets that we're aiming to sell to, or because they are interested in the potential of the technology in the future, that they are interested in being close to and having a stake in a company that will develop new technology that can affect their markets, that can affect, or build new markets where they could play, or that can, help them solve some of the problems in their industry. So we've focused, and so that has been the major source of funding for us over time. There are, and there will be more space-focused venture firms, and there will be more experience in successful exits and successful stories in the space industry over time that I think would allow to develop a more active venture ecosystem for space. But for the time being, I would think that it's probably not the easiest source of funding for space startups. The other thing that plays against that is that venture capital firms are typically on a specific timeline, right? Depending on where the cycle of their fund they are, but typically investment cycles for a venture capital fund are 4 years of investment period, and then 4 years or 5 years of divestment periods. Basically, in 8 years or 10 years, you have to essentially go through the whole cycle of the fund. And space takes a little bit more time, right? Space is not, you will not develop a company to fruition, let's say, and to maximize return in an 8-year or 10-year period in general. I think for any project that that has the potential to be industry shaping, it's going to take you more time, and that doesn't adapt very well to the venture capital mindset and the way the venture capital investment vehicles are structured. So I think that's also an argument and point for going for more the route of angel investors, individuals, family offices, and strategic investors as potential sources of funding, until you can actually prove that you have the growth to start qualifying for private equity or eventually public markets, right?
Yeah, absolutely. And with respect to your strategy on which really the pockets of data to focus on, I saw that you're trying to do like sub-meter multispectral and like 30-meter hyperspectral or so on. What was the logic behind this? Was it that Sentinel and others are giving out a little bit coarser resolution at free, and you want to focus on sub-meter at a lower price point? And also the hyperspectral, I guess it was something very new when you started, and were you exploring like some of the new applications there?
Yes, sub-meter is really necessary for most mainstream applications for Earth observation data, right? Now, the way I talk about it is, look, there's a reason we call the meter a meter, right? And it's not a different size. The reason is this is where human activity happens, right? This is the scale at which human activity happens. And so I think it's not a coincidence that that's kind of the threshold when you start imaging at a meter. And actually, if you consider Nyquist sampling, get to maybe 50 centimeters, where you can actually see things that are a meter, in a good with good contrast. I think that's the point at which you discover most of the mainstream applications for Earth observation data. And so we have been focused on this measure, and we have been focused on opening up the Earth observation markets for mainstream applications. That requires two things. It requires hitting the right resolution, and it requires hitting the right combination of frequency of data acquisition and cost. So you have to, be able to collect data reliably. You have to be able to collect, so reliably in the sense of, if I want data every day, I need to have a source of data every day. If I need data every week, I need to have a source of data every week, right? You need to have a reliable source of data. You need to have it at an affordable price. And you need to have it in a way that, that is usable, that people can access it and tap it, that is, and that combination, frequency, cost, usability, reliability of the data source, this is really where I think the market is going to be played in the next few years, is who hits the infrastructure in orbit to be able to deliver data to customers effortlessly at the right resolution, at the right cost. And that's the vision we're after. We basically want to build what we call a information utility from orbit, right? We want to build something that is similar to you going and opening the water faucet on your home, right? You just open the water faucet, the water comes out, right? And you drink it, you do whatever you want with it, or you plug into your wall socket and you get electricity, right? The ease of use and the reliability of utility, and the affordability of a utility. This is what we're going for, but for Earth or geospatial information, right? And to do that, well, it's complicated to realize the vision. There's a lot of technology factors, but mostly there's a factor of being able to distribute data, at the right cost, and the unit economics become really important. And that's kind of been the driver for technology development.
Yeah, what is also interesting in your story, or at least what I've read so far, is that unlike the typical American new space startups, which then go on to typically get a lot of military-based grants to keep their company alive while they scale up, their Earth observation systems, you seem to focus more on just getting the markets to absorb your information and data. And what do you think about this, or this approach that traditionally I see a lot of American companies just raising money and then going after NGA contracts and the typical military realm to I guess get some kind of a money runway to extend their their lifetime, I guess, to build up their constellation?
So I think it's a byproduct of the cost of data acquisition and distribution, in a sense, because when the cost of acquiring a square kilometer of data and distributing a square kilometer of information to your customer is high, there's just not it doesn't matter what the resolution is, but there's just not a lot of applications that can support that. I mean, if you're thinking, small farmer in India, for them to use satellite-based information to improve the decision-making in how they plant or harvest crop, if they have an average of 1 or 2 acres of land, first of all, the cost of the survey needs to be low enough that it actually makes sense, right? Secondly, they're not going to want the satellite image. They're going to want information that's processed and transformed into something that they can relate to, right? And so you have to hit all these different things to go after that market, right? And it's hard. I mean, if you have a high resolution imaging satellite, Landsat, for example, or this Pablo or Sentinel, they're just collecting data over the surface of the planet, at low resolution or mid resolution, but they're distributing the data very cheaply. And this data, you can think of how to use this data to build applications for anybody, because the data is essentially is free. But when you go to the problem is you cannot use this data for 1 acre or 2 acres of land, right? Because your pixel size is bigger than that, and or not exactly, but you only get a few pixels, right? So you need high resolution data. When you go to high resolution data, the way we operate satellites today, you have to point high resolution satellites to their targets, and and there's an opportunity cost there, and you have to transfer that opportunity cost to customers, and that opportunity cost ends up being the driver of the cost of data in the hands of the customers. And until you can drive that down, you will only cater to applications where the customer can pay for the opportunity cost, right? And look, you can do this in many ways, in any way that you want, but I think in the end, what happens is the only customers out there, they're not looking at the cost, just looking at the value that they can get from the data is the defense and military customers, right? And so I think that's the reason why every other company in this industry has focused there, because those are the ones that essentially can pay the data at the cost that is being acquired and the cost of distribution. We're trying to do something different. We're trying to really democratize access to higher resolution data. We focus a lot on unit economics. We focus a lot on our distribution cost so that we can actually hit the right combination of resolution, frequency, and also affordability, so that we can open up some of the mainstream applications of this technology. And so we have a company-wide policy that our technology is used for peaceful use only. And really, that we want to democratize and give everyone the ability to use the sources of data to improve decisions on real problems, like we were saying at the beginning, right? Water, energy, food, the things that we believe will make all of us better off, in a sense, right? So that's where we're in.
Yeah, actually, well, one of the things that I did is actually did my PhD on looking at satellite data analytics in the supply chain context. So really integrating satellite big data into end markets, including agriculture, energy, and other things that you talked about. But I had an India focus, completely India focus. So one thing that I saw, through this time when I was doing my PhD is that there's a lot of B2B markets that you can unlock. Certainly, there's some B2B markets that you can definitely unlock when it comes to these agriculture and other aspects. But when it comes to a large portion of the administration of things like water, agriculture, there's a very heavy hand of the government in either providing subsidy or either providing programs or providing access to credit or insurance and many other things. There's a lot of government involved in all of that. And of course, the other part is that there is almost no affordability, or it is extremely difficult to build a B2C model. It may not be a business to customer. I call it a business to citizen model. So that's very challenging to build, because just the appetite to pay for something like that in a small farmer in India does not exist, right? So you have this niche of B2B that you can exploit, but the real big opening comes from unlocking this B2G kind of models, where you have the government replace the traditional methods to use your satellite data in creating this efficiency in the programs and the subsidy programs and the other things that they have, right? So how do you overcome all of this? And do you see a market for this I also see that, for me, I think like markets like Europe and US are very saturated because there's too many players and, too many players fighting over the same pie. But I see more scope for a country like India or Africa, where there is very little market understanding of somebody who's coming from US, of the local environment in India. And there's a lot of opportunity because there's absolutely no such tools being used currently. So where do you see, out of the two things, how do you see this evolving?
Yeah, so I have this vision, really the key here, honestly, to be able to tap into any of the applications that you mentioned, the real key here is the cost of data distribution to the end customer, right? Once you fix that, you can enable, whole wealth of new value-added service companies that will take the data and transform it into something useful. It's just a matter of hitting the right price point. And with any new technology, in a sense, you have what you have with, or what has been happening with Earth observation data, right? At the beginning, you see the potential of this technology. And the most important thing here is that when you think about the potential of Earth observation data to solve all these problems, it's very clear how you can use the data to solve the problems, right? I think this is the most fundamental part. So if you can just hit the right price point and the right frequency, the right resolution, this is going to be useful in all these different industries, right? So what happens with this new technology is when at the beginning, people see this potential and they essentially overestimate the capacity of delivering on this potential in the short term, right? So the expectations grow faster than the speed at which you can actually deliver on those expectations, right? And that is very, very common. And then at some point, people start to get disillusioned because basically say, look, we've been hearing about this thing for 15 years and it's never happened, right? So it's never going to happen. And then people start correcting in the opposite sense, and they start, underestimating the potential of actually reaching the inflection point where you can actually deliver on the promise. And I think this is exactly where we are today in the Earth observation market, right? People have been disillusioned by 15 years of promises that were not fulfilled, and are basically saying, look, we've been hearing about how Earth observation is going to solve all these problems, and nobody's delivered in this, so it's just not going to happen in our lifetimes or whatever, right? And I think it's a great point to be at, because we will surprise people. We will be able to deliver on these promises, and it will happen significantly faster than people expect. And it's normal, right? I think this is a normal for every industry, for every new technology development. It's a very, very similar pattern, where expectations follow this kind of sigmoid form, around the true rhythm or path of development that proceeds slowly and eventually gets where you expect it will get, right? So I think it's managing expectations is the most difficult part, but the potential for this industry is huge, and I'm sure we will deliver on it.
So from what you're saying, you seem to be looking at more, positioning yourself as a data provider, and not really going vertically integrating towards an application, provider, right? So are you looking at also vertically integrating towards specific applications?
We have been working on vertical or specific applications for vertical markets, and because when you're building a platform, you need to, in a sense, understand how applications are going to be built and how they're going to be delivered. And if you don't do the end-to-end applications, it's very hard to build a platform that is actually useful, right? So we have been doing that. We expect to continue to do that for customers strategically over time. But yeah, the main goal for us would be to become the enablers of new generation of value-added service companies that can use a new data source to and add on top of it the specific vertical expertise or specific local expertise, needed to deliver winning products in small market niches all around the world. And we believe there's not going to be one company that concentrates all of the applications of Earth observation for sure, but even in verticals, there's not going to be one company doing data for agriculture, right? And delivering on the promise of agriculture in general. Agriculture is 1,000 different things, and the same crop in different places in the world means probably a completely different problem. And so we believe there's a lot of room for local companies to figure out things locally and use best available technologies and best available data sources to solve local problems. But I think that's going to happen in a bunch of different industries, right? Where local problematic is specific enough, and where distribution channels locally are specific enough that you're going to need the granularity of a large value-added service base to deliver Yeah.
All right. So just the last couple of questions to you before we end. I know you had a long day already with the launch. So just the last couple of questions I have is one, you see now synthetic aperture radar, even now medium resolutions, I guess, hyperspectral people trying to do that, maybe some things in thermal infrared as well. How do you see these unlocking in the next coming years against what you're doing already with the high resolution multispectral? And, do you see all of them necessary for the whole ecosystem of data to be successful for applications? That is one part of it. The second part I wanted to ask you is, having done this for now 10 years in a country based like in Argentina or even in Uruguay, and having centers in other places now, has the mindset of policymakers in places like Argentina and Uruguay changed to support new policies or new development so that more people can like you can do stuff?
So on the first question, the customers don't care where the data comes from, right? I mean, honestly, the customers don't care about the data. Actually, they care about solving the problems, right? So it's if it comes from a satellite, or if it comes from a drone, or if it comes from a person with a magnifying glass that's going to take a look at every leaf in their crops. I mean, they couldn't care less, right? What they care is that they get a solution to the problem at the price point that makes sense, right? What I think happens also is that there's no single source of data that is going to solve every problem for every customer, right? It's just not going to happen. So different, sources of data have different uses. Most of the value is going to come from combinations of sources of data. So, when you can mix radar with optical, with hyperspectral, with, signals coming from sensors in the ground that you're collecting from an IoT platform, with AIS and with, RF monitoring platform and whatever it is. When you have all this wealth of geospatial information, again, you also have the public data sources of lower resolution data, and then you have higher resolution data sources that can give you more granularity. I think that combination is going to be the key, and it's going to be the powerful tool that we will use to basically solve problems. So I think more sources of data in orbit are better for all of the industry, basically. I think, this is the Earth, there's a lot of stuff going on in the planet. We are supply limited in terms of data sources, so the more data we can collect today, I think the better. We do see a lot of complementarity, with SAR and optical. We see a lot of applications with that complementarity. Is very, very important. Also, I hope to see, more thermal infrared or higher resolution thermal infrared. I hope to see more higher resolution hyperspectral in the market. So all of these data sources, I think, are useful. What happens in the end is all going to turn around cost of distribution of the data to the end customers, and how that data at the price point that you can get it can support different kinds of applications. So unit economics, are going to be the driver. At some point, for some applications, it's going to be okay. You're going to say, look, with this data source, I'm processing it this way, I can solve 85% of the problems I have with this particular issue. And then for the last 15%, okay, I might need to send someone there to take a look, or I might need to use a very expensive data source for the last 15%. And that's going to be okay in a sense, right? Because you're basically trying to solve a customer's problem, right? So I think that's one way to think about integration of different data sources. I think it's going to be the key for the industry, right? On the other part, you asked me about countries' regulations and how they can support it. And I think countries need to realize, and governments need to realize, that they're essentially competing for companies, in a sense, right? Companies are today in a situation where you can decide to locate different parts of your company and to add value in different ways in different countries, depending on the resources that you have available in each place. And that comes from the whole process, the whole life cycle, from design to, to component manufacturing, to assembly and integration, to launch, to operations, to processing of the data, distribution of the services, sales and marketing, financial structuring. Like there's a whole bunch of things that you do in the life cycle of a company or a product. And for each one of the portions of that life cycle, you can actually choose the right location. So countries need to get on the mindset that they are essentially competing for locating or receiving, some or all of the portions of what a company does, and setting the environments where where that actually makes sense. So to that extent, you can start doing R&D in Argentina as we do, do the design there, but then you manufacture as we do in Uruguay, and then you set up, a value-added product team in Barcelona, where I'm currently at. And you can pick places based on the talent that you have available, based on the context and the regulation. And I think we need to get used to it. Yeah, that's kind of the world that we live in, and countries need to get into the mindset of of how they compete for companies to locate there and to essentially in the end pay taxes there, right? Which is what countries want. so I think that's how I would think about it.
So Emiliano, thank you very much for being a guest on. So I think it's one of the most insightful episodes I've ever recorded. You having discussed so much the intricacies of coming from Argentina, learning about all the hoops and making it work to make the whole thing work. So I think it's one of the most insightful stories. I think there's a lot of lessons for us in India, and also for the government in India to review, things like this. And hopefully we'll see more of our entrepreneurs take notice, and hopefully, some of them can also replicate what you've also done in the process. So thank you so much for taking time.
Thank you, Narayan. It's been a pleasure. Thanks for thoughtful questions.